The purpose of this video is to give a homework head start when working on what would be worksheet 23 for pre-AP or worksheet 28 for on-level students. They have the same content about solving one-step equations, and this is a follow-up to the notes where there were 8 examples and we solved using balance beams, we solved using proper algebra notation, and we checked our solutions by substituting our solution back into the original equation to see if we got true statements. There are 2 that are already done for you. This is available on Google Classroom to be printed or done on notebook paper. For the first example, the equation is c plus 3 equals 11. We had not completed a thing called a do-undo chart before on the notes. However, it was discussed, and this is inverse operations. The first thing to do is focus on the side of the equation that has the variable in it. Here, the left side of the equal sign has the variable c on it. And you want to see what operation you are doing to the variable, if you are adding, subtracting, multiplying, or dividing. In this case, 3 is being added with c. So I'm going to write that that is the thing that is being done. Then I'm going to think about inverse operations, also known as the opposite operation. The opposite of adding 3 would be subtracting 3. You will get credit for completing the do-undo charts with the operation and what the inverse operation would be. Then, whatever you say, you will have to undo in order to solve. That should be demonstrated in your solving work. Observe that on the left side of the equation, 3 was subtracted. Adding 3 and subtracting 3 essentially cancel one another out. And I sometimes like to cross through this canceling out. I find it very satisfying, and it helps my mind only focus on the c, and then I'll just bring that down. On the right side of the equation, 3 was also subtracted. 11 minus 3 equals 8. So we believe that the value of the variable c is equal to 8. But there is a way of checking that. The original equation can be written, and then wherever you see that variable, go ahead and substitute in the solution, and then work it forwards again to see if you get a true statement. 8 plus 3 equals 11, and 11 is in fact equal to 11. Even though this might have been something that you could do using mental math, we're really not interested in you saying, oh, the c is equal to 3. We are interested in your plan. We're interested in the algebra notation that you're going to be using and the checking work. We're just picking easier equations to practice our algebra skills on for the first time. For the second example, I see n over 2 is equal to 4. And if this one were not done for you and you couldn't already see the process, you would have to think, okay, focus on the variable. When I see a fraction, does the fraction mean to add 2 or to subtract 2 or to multiply 2 or to divide by 2? And one of the first math lessons we covered in the school year was that fractions can also be division. What is being done to the variable, the n, is it's being divided by 2. To undo that, the inverse would need to occur, which is multiplying by 2. And then that inverse operation needs to be carried out. It's carried out multiplying by 2 on the left side, multiplying by 2 on the right-hand side. What you do to one side, you must always do to the other side of the equation, because equations are about equality. And if you did one thing to side of the equation that you didn't do to the other, you would no longer have equality. That would be unfair treatment, if you will. If you're kind of thrown off by the fractions, don't be. I'm still showing the n divided by 2, multiplying by 2. If that 1 were not right there, what you could do is you could just say, oh, if I divide something by 2 and then multiply it by 2, it essentially cancels out. However, the explanation is here if you really wanted to see what's happening behind the scenes. If you multiply n times 2 numerators, that would give you 2 n's. 2 times 1 denominators, that would be 2. And then when you simplify this, that would be the same as 1n, and anything times itself, identity property says, is simply equal to itself. And then 4 times 2 would be 8. So we believe that the value of the variable is also an 8, coincidentally, again. In order to check the work, take the variable value, substitute it in, and then work through it again and see if you get a true statement. In this case, 8 divided by 2, that could also be written 8 divided by 2, which is 4. And 4 on the left, 4 on the right, that is a true statement, so I know it's correct. Moving forward, please do the same things for the rest of these and for the accompanying page to put what operation is being done. For example, plus 5. How would you undo it? You'd have to subtract 5. Your scratch work should show that. Taking away 5 to where these cancel, and taking away 5 to get your solution, and then substituting that back in, and hopefully you get that it equals 14 again. These will be graded separately when I go through and check your work. Good luck to you.